All right, so we are now in a new unit. This is the trigonometry unit. So the first thing we're going to learn about are angles and how they're measured. So we're going to talk about angles, degrees, radians, areas of sectors, and all of that. So in this section, you'll be able to find the degree and radian measure. You will also be able to determine coterminal angles. And then you will also be able to determine arc length and area of a sector of a circle. So we'll talk about what all of those things are. So the foundation of this section is angles. And so how we measure angles and what an angle is very important. So here's the definition of an angle. An angle is formed by rotating a ray around its endpoint. All right, so this is a ray. So you may have seen this in geometry. It's just a line that has like an arrow, so it goes on forever. So if we take this line and rotate it around, the space we make in here is called an angle. So the starting point of our ray is called the initial side of our angle, and the ending point after we rotate it is called the terminal side of our angle. So we talk about initial and terminal side a lot. And then here, this is just called the vertex, the end point of the ray. Okay, so we will talk a lot about standard positions of an angle. So here are different types of angles we have. So this would just be a straight angle, so it's a straight line. A positive angle is one that starts at its initial side and goes around counterclockwise. This makes a positive angle. And if you start here and go around clockwise, that makes a negative angle. All right, so an angle is said to be in standard position if its vertex is at the origin, and then its initial side is on the positive x-axis. So we'll draw pictures of this. An angle is positive if it's rotated counterclockwise, negative if it's rotated clockwise, and so be familiar with these. We often use Greek letters to name our angles, so like alpha, beta, theta, gamma, and phi. This is the one we most commonly use. We use a theta to represent our angle a lot. So number 1 says draw a positive angle theta in standard position with its terminal side in quadrant 3 and a negative angle beta with its terminal side in quadrant 4. So it's using all of that vocabulary we just got. So first thing we note, we want a positive angle theta in standard position. So let's remind ourselves what that means. It means the vertex of our angle is at the origin. So we can draw an XY axis. All right, and so for our angle, the endpoint needs to be at the origin. Its initial side is on the x-axis. That's how you know it's in standard position. And so we want a positive angle, so we want to go around this way, counterclockwise. And the terminal side needs to be in quadrant 3, so 1, 2, 3. So we want to end it somewhere over here. So from here all the way over is our angle theta. So this is a positive angle, it's in standard position, and its terminal side is in quadrant 3. Second thing we want to draw is a negative angle beta with its terminal side in quadrant 4. So we also want it in standard position. Okay, and we want the terminal side to be in quadrant 4, but we also want it to be a negative angle. So instead of going this way and ending in 4, we're going to go clockwise and end over here. So this would be our angle beta. All right, so again, where we start, this is the initial side. Where we end is the terminal side. And then the space in between is our angle. Okay, so let's talk about degrees because we've heard about degrees a lot. All right, so those angles we just drew, we can measure them using degrees, and so it's noted by a degree symbol. So for example, if I had XY axes just like before, okay, so if we have an angle that starts and ends right here, this is known as a 0 degrees, so it's a 0 degree angle. We haven't gone anywhere. All right, if we go around, we get to a 90-degree angle, and you'll often see 90-degree angles notified with this little box here to say this is 90 degrees. So from here to here is 90 degrees. All right, and then we can add another 90, so over here would give us 180 degrees, then 270 degrees. And we can actually keep going around and around as many times as we want. So if we go around 270 all the way back, this gives us 360 degrees. We could go some more, add another 90 and have 450 degrees and continue going around. We could also go in a negative direction, starting at 0, going this way. Down here also represents negative 90 degrees. All right, so certain angles have special names. If our angle is between 0 and 90 degrees, it's called an acute angle. If it's exactly at 90 degrees, it's called a right angle. If it's bigger, so between 90 degrees and 180 degrees, it's obtuse. And then if it's a straight line, we just call it a straight angle. So the question is, how many degrees is a full circle? So how many degrees does it take to go all the way around? That would be 360 degrees. So I think we're all most familiar with using degrees to measure angles, but in our class, most of the time and all of the time in calculus, we actually use radian measure instead of degrees. So let's talk about what radian measure is. All right, so to define a radian measure, we're going to use a circle, all right, where the radius of our circle is r, and the central angle, so the angle here, is theta. And we say theta has a measure of 1 radian if it intercepts an arc length equal to the radius. All right, so here, this is the radius of our circle, and this space around the circle, the opening created by our angle, this is called the arc length. All right, so in this picture, the radius is r, and also the arc length is r. So the way that we will measure our angle, theta, it's always going to be our arc length divided by the radius of the circle. So this is always how angle in radians are defined. Arc length divided by radius. All right, so notice our arc length is given by r, so this distance is r. Also, our radius is given by r. So that means this angle in this picture has measurement 1 radian. Okay, so let's look at this example. It says if a circle has a radius of 5 and theta intercepts an arc of length 10, what is theta? All right, so first we have a circle. So let's draw that. And it says the radius of that circle is 5. So from the center of the circle to the outside, the radius is 5. All right, and then there's an angle in here that intercepts an arc length. So maybe here's our angle. You can draw it however you want. And this arc length out here, they say is 10. And so our question is, what is theta? All right, remember how theta is defined. It's always the arc length divided by our radius. In our picture, our arc length is 10. Our radius is 5. So this angle has measure 2 radians.